Assalamualaikum and very good morning. Welcome to the lecture for week 4. So for lecture for week 4 is the continuation for chapter number 2. So last week we have already covered the um, fluid characteristic and behavior, starting from what is mass for fluid until the last one on the viscosity. So we have two viscosity, which is absolute in kilogram over meter second, and we have kinematic viscosity in meter squared over second. I'll stop. So we will continue our class for this lecture. So of the natural phenomenon that happening in our fluid, that we can make it into a very scientific application. So for this part, we will start with the what is cohesion and adhesion. Cohesion and adhesion is an attractive force between material bodies. So that is the general statement for cohesion and adhesion. But then for cohesion, or we call it cohesive force. Cohesive force is actually force which act to hold together the like atom, ions or molecule of a single body. So for example, this is the inside our fluid. So inside of our fluid, they have internal force, attraction force. So it will act on all part of the molecule, and it will hold together all the molecule. So that's why we have a body like a liquid have more or larger value of cohesive force, because it is more compact. Because of the cohesive force are more compared to gas, which gas still have cohesive force, but then in a smaller magnitude. So the molecule of water droplet are held together by cohesive force. So for example, if we have water, so inside here, if we have water, so inside the water, so inside it we have a molecule, and each molecule has an attraction. So they attract. So over here, and then we will have another molecule over here, another molecule over here. So cohesive force is actually the force that bind the molecule together. Okay, the second one is the adhesion, or we call it adhesive force. So adhesive force are forces which act to hold two separate bodies together. So cohesive is the internal attraction force in one body, but then for adhesion, between two bodies, or two separate bodies together, or to stick one body to another. So it acts like a glue. So you already know about adhesive. So it acts like a glue from one body to another body. So this is usually happen if the contact between liquid and with solid. So the adhesive force between water molecule and the glass, a wall of a glass tube, are stronger than the cohesive force led to an upward turning molecules at the wall of the vessel. What is mean by this? So for example, if you have one a glass tube and you have water, kan? So originally the water will be like this. Okay, we know that on the bottom over here we have the cohesive force. So it will attract every part of it together. And then we have adhesive force. So adhesive force is the force that stick two separate bodies. So we have water and then we have the solid over here. So it will start to bend like this. So and then they have a force because right here on the in the middle of the body we have a very symmetry cohesive force. But then at the surface, for example, at the surface like this, so the force are not totally symmetry because it only has force for the downward part. But then because this is the surface, there are no forces pulling upward. So there are more force pulling downward. So we will go down. So this surface will go down and on the edges will go up. So this is what happened when we look at our glass. Then we have meniscus. So at the end we will have a meniscus like this one. Okay, so because of that we have surface tension. So surface tension is the tendency of a liquid to reduce their exposed surface to the smallest possible area. So because if we have a body of water, so initially it will be like this. So because it has internal cohesive force, the cohesive force will attract each other, and at the end we will get a complete sphere-like droplet. Because when everybody is acting on its own, every molecule has act on its own cohesive force. At the end we have a equilibrium, so we will get a droplet. So because of this we have seen a phenomenon. For example, a small insect walk on water. So what happened is the cohesive force is more larger than the weight of the insect. So the weight of the insect is very small because it's very small and very light, and then the cohesive force inside of the water is bigger, so that's why the insect can walk on the water. And then we can have the soap bubble. When we have bubble, why bubble? We look it always being on the sphere, like it doesn't have bubble triangle or square like that, because every molecule inside of the bubble are attracting each other in a symmetry way. Then we have water beads on a flower petal and water droplet for it. Okay, so the liquid droplet behave like a small spherical balloon filled with liquid, and the surface of the liquid acts like a stretched elastic membrane. This is how to visualize what is happening inside the droplet. So with droplet, so we imagine that in the middle we have a liquid, and on the outer side it is like an elastic membrane, like one membrane on the outside. So the pulling force that causes this is due to the attractive forces between molecules. So because in the we have the attraction inside of the droplet, so we have the attractive force or the cohesive force. So this is what happening is the surface tension phenomena. So when the internal molecule has attracted all the molecule symmetrically on all over the side, at the end we will have a surface tension on the outer layer of our droplet. So attractive force on the surface of molecule is not symmetry. This is just like I said before. So on the inside we have symmetry, cohesive force, but on the surface it is not symmetry. That's why we got it. That's why right here, so the force are not symmetry. So we only have the inward, so it doesn't have the outward one. So that's why at the end it will be like a sphere. So then repulsive forces from interior molecule causes the liquid to minimize its surface area and attain a spherical shape. Okay, for example, so this is the same the description also for surface tension. For example, we have the uh, molecule I, which is molecule I over here. In the interior, experience and attractive forces from neighboring molecules. So we have a lot of molecule over here. So it experience attractive forces from neighboring molecule which surround all the sided. But then the molecule on the surface have neighboring molecule only on one side, only on the, for example, this one on the below side, on the inside. Thus experience an attractive force which tends to pull them into the interior. So it will tend to pull it downward. Okay, so you can also look at this one. This is the other description on what is surface tension also. So for surface tension, the unit will be Newton over meter, and this is the standard surface tension for uh, several standard fluid that we are using. For example, water. As you can see, for water itself, the surface tension varies according to the temperature, because the higher the temperature, the lower the surface tension will be. And then this is the value for glycerin, oil, mercury, and all. Okay, because of this surface tension, we see droplet, right? So when a liquid contact a solid surface, the line of which liquid, gas, and solid meet is called the contact line. The degree, the contact is called the contact angle, and it is measure of the quality of wetting. So this is the first time we know what is wetting. We heard about wetting. What is wetting? So the net surface tension acting on a contact line depend on all three material, liquid, gas, and solid. So the forces balance on contact line show that surface tension for uh, solid gas minus surface tension of solid liquid equal to uh, surface tension cos theta. So what is the meaning of this? So, sorry. So for example, for this one, so when a droplet of water contact with a solid, so we have solid on the bottom and we have the water inside, up on the uh, on the surface. So when they meet, we will see various attraction or various phenomena. For example, for this one, when this liquid not necessary water, so one type of liquid contact with solid, it will have a very smear like wait, phenomena like this one. So from this one, we can calculate, we can measure the contact angle. So from the edges, so we have this tangential line, and then we get this angle. Okay, and then every type of liquid will act differently. So every a liquid in contact with solid, they will have contact angle differently. This is based on their own apa nama ni, surface tension value. Okay, so how can we say which one is wet, one is non-wet? Okay, so for this one, if you can see A and B, if we look at here, the surface area covered by this droplet is very large, and the contact angle, if we compare contact angle over here, contact angle over here, the contact angle is less than 90. So this means when the angle is less than 90, we have a very big surface area covered by the droplet on the solid. But then, for example, if we see a phenomenon like this, so the contact angle is very big, and then the contact area is very small. So if we compare between these two, which one is we call more wetter than the other one? So this one, A and B, is more wet than C. So for this A and B, we call it as a wetting, and for C, it is non-wetting. So if the angle is less than 90, it is wetting. If the angle is more than 90, it will be non-wetting. So this is how to consider the wetting phenomenon. So this is happening to us also when we have rain. How we can say we are wet? When we have a lot of water on our clothes or on our body. But then if we have less water, so we say not too wet. In this phenomenon, we call it non-wetting. Okay, so because all of that, so we know that addition and cohesion phenomenon will at the end create capillary effect or meniscus. So meniscus either can be on top of water where we have H, or if we have the cohesive force is much greater, for example for mercury, so H actually is on the downward part. Okay, so if we have like this one, like water, because the water, the cohesive force is not too big, so it will be rise. The water will rise. But then for a very heavy liquid like mercury with a density of 13,600 kg per meter cube, it will go downward. Capillary effect is the rise or fall of liquid in a small diameter tube. The curve-free surface in the tube is called meniscus. So water meniscus curve up because water is wetting. So if you see, curve up, so the area over here is bigger, so we call it wetting. But then for mercury, meniscus is curved down, so it curve down like this. Wait lah. Going down, and then the contact area is very small, and contact angle will be more than 90, so we call it non-wetting. So we can calculate the rise or the falling downward of a capillary effect. So we are using the formula like this one. So H equal to the rise or the drop, depend on the liquid, equal to 2 sigma cos theta over rho gr, which is this surface tension, and cos theta is the contact angle, rho is the density, g is gravity, r is the radius of the tube. So remember the radius, rho gr. And if you can see, all need to be in SI unit. So make sure when you are doing this, make sure all with the same uh, apa nama unit. Okay, so we try to do this one. So for this example, suppose that in this figure R is 1 mm. So we know, so the first step we will take out what we have, 1 mm. So for me, I will take out what we have first, and then convert to the SI unit. So 1 mm equal to what? 0.001 meter. And then they give theta, which is the contact angle, equal to 0. Sigma, which is the surface tension, 0.073 Newton over meter, and density equal to 1000. Even though density is not given, we know this is water, so we use 1000. And then we put it in our formula. H equal to 2 sigma cos theta over rho gr. So 2 times theta sigma 0.073 cos 0 over rho is 1000, gravity 9.81, and radius is 0.001. Okay, so actually there are also the solution on the back, so we can check it out. So we have another one, you can try it yourself, and then if you have any problem, you can come back to me. Okay, I think that's all for chapter 2. So we will meet next week for our tutorial session online, still in online. If you have any problem, you can come back to me. So, Assalamualaikum and thank you.